For day one is basically an icebreaker. We just asked a couple questions and we answered them and we wrote down our answers. For day 2, we used cosine function to calculate horizontal distances in a unit circle. For day 3, we used the cosine function to calculate horizontal distances in a unit circle. Right here it says on a unit circle and graph of cosine function. The x-axis is the cosine function and the sine function is the y-axis. On day 5, we use special right triangles and reference angles to label the exact value of the coordinates on a unit circle. Right here is a picture of a unit circle. These are all the degrees and radians and cosine and sines and quadrants right here. For day 6, we located and found out all of the radian measures for the special right triangles in a unit circle. Right here is a picture we drew, which labels all of the radians. For day 7, we sketched the parent graphs of the functions sine x and cosine x using the 5-point method. Right here's a couple examples. Some more examples right here. For day 8, we investigated the graphs of the function sine x and cosine x. They do not have the period of 2 pi. Right here, there's a couple examples also. For day 11, we were able to recognize piecewise functions. Piecewise functions are defined as a function that uses different rules for different parts of its domain. Right here's a couple examples right here. For day 12, we recognized the sigma notation as a compact way to indicate sums and right sums in expanded form. Here are a couple examples of sigma notation. Well, these are kind of like the long ones actually. For day 13, we use sigma notation as a summation in expanded form with algebraic expressions. Right here, there's a couple examples. For day 14, we found the area of irregular shapes using under a curve for different functions. There's a couple graphs right here. For day 15, we'll be able to formalize technique for estimating the area under a curve and find out how to better estimate the area. For day 16, we estimated area under exponential functions using sigma notation and compare negative and positive areas. Day 17, we estimated the area under a curve using trapezoids to improve estimates and compare with rectangles method. For day 18, we reviewed how to estimate area under the curve using trapezoids in sin x and lower. There's a couple graphs right here. For day 19, we found an exponential function of form y equals ab squared x that passes through 2 points and solve real life world situation. For day 21, we reviewed the properties of exponents and find equivalent exponential equations by using their transformations. For day 22, it was an ed puzzle. So what we did was we had to graph an exponential function with an equation y equals abx plus c. This is day 23 and 24. Students will be able to redevelop the log function by reversing a table for an exponential function practice, converting between exponential and log equations, and define the log function. Right here's the table we used. For day 25, we recognize and use the log rule or properties of any base to solve equations for the form ax or a squared x equals b. For day 31, we simplified trig expressions by rewriting functions in terms of cosine and sine. And for day 32, we determined whether two different looking expressions are really the same.